it's on our YouTube channel. The only especially as if you can hear. It's a little strange.
Why is it oh, why is it quiet?
And this is a little strange. Let's see. Normal.
Is it the resolution?
No.
Good enough.
Well, it's not showing what it's supposed to be showing. The link change. Yeah.
Oh, that's good.
It randomly changes the thing, so let's try and copy that. This must be good. It randomly changes. We don't. So what I like to do is test it, because this is such a horrible setup that just because we're not hearing anything doesn't mean that there's no sound. But it could.
This thing wouldn't give you sound. No,
Well,
it's supposed to.
it can if you select the right outputs out of the four possibilities.
The clock is off. Like by 2 hours.
Yeah. No, it probably is. Last time I opened it, it only updates when the minute changes.
But she's every minute.
Yes.
Okay. Oh. Oh yeah, of course.
There's sound.
Is there sound here? Maybe?
Yeah, I'm hearing something.
It's delayed.
Okay. Might have to talk loudly.
Okay. Okay.
Oh. Keep an eye here.
Okay. So good morning, everyone. Sorry for a little bit of delay. We're trying to set the live stream. So good morning, everyone.
Good.
Yeah. Okay. So it works. I have to sit because I need to be close to the microphone, so somebody on the other side of the world or wherever they are listening to us can actually hear. So today we're going to gently introduce you to our supercomputing powers. First of all, who of you already maybe have an account? And okay, you have account. So if you notice, we work here with Windows, right? So the thing is that when you work on a supercomputer, you don't have Windows. You don't have Windows at all, like no Windows, no mouse, nothing. And that's why I'm a little bit confused, because most of my day I work with just printing. And that's what you're going to do if you will be using our supercomputers. And why is it important? Well, because Windows could be slow. And by Windows, I don't mean the Windows system by Microsoft. I mean any sort of graphical interface where you drag with your mouse, you input something by clicking. And that's why originally people were using terminals. So what is the terminal? Most of you might be familiar with that. If some of you are not, then you can think of it as a text editor, basically, where every time you run a command, good morning, computer will execute it. It will run it and it will do something for you. So you don't really need to see sometimes the windows or anything. You just need to run the command and read the output. So that's how you interact with computers using terminal. If you have Mac computers, you already have terminal installed on your system. If you have Windows computer, which I see some of you have, you would need a program. For example, there are several programs, but one of them that we recommend usually is Mobile Xterm. And because some of you might be working with visualization, you would like to maybe perform some research on, I don't know, some stars, and you would actually see something. You maybe want to see some MRI. And on a supercomputer, you can view, but it's not the most pleasant thing to do. But if you're forced to use graphical interface, it's possible. So this is just the starting of how you interact with a supercomputer. So you would need to get familiar with terminal. So terminal is the program that you use to connect to the server, to our computer. Today we are having 2 more sessions, and I think one of them is about actually using terminal. And if some of you are not familiar with the basics of it, one of my colleagues will introduce you to the basic commands, how to run it, how to view the directory, how to run the commands. It's very simple once you learn the very basic commands. So instead of basically clicking somewhere and opening the folder, you will just type the command, like go into this folder and show me the contents. The same thing, and you become very fast at it. You don't really miss this windows anymore. So let's just continue talking. So first of all, our system is a part of a bigger services that Canada offers to the researchers. And we work under umbrella of so-called Compute Canada organization, which basically means that we have several big systems for supercomputers and a couple of clouds under Compute Canada umbrella. And as a researcher, once you get access to the Compute Canada account and SciNet account, which is very simple, it's free, you don't have to pay anything for it, you get access to this enormous power. We will talk about how powerful our systems are. But we will be talking about our system, first of all. So the system are scattered around Canada, and 3 of them, Graham, is located at University of Waterloo, Niagara. Oh no, sorry, 2. And Cedar is located in British Columbia, and we just got a new system in Quebec called Beluga. They all kind of similar and at the same time a little different. We are more different than others, which basically means that our system called Niagara is meant to be used for very large parallel computations. The difference is that the general purpose clusters like Cedar, Graham, or Beluga allow you to work basically, I don't know, 5 cores, 10 cores on the computer. The way we work is that you are given a computer with 40 cores. So is everybody familiar with what cores are? And just raise your hand and I will explain if some of you are confused a little. So your computers right now most likely, since we are a little bit, in the modern era, most of you probably have several cores inside of your computer. So you have a processor, a main processor. It's like a brain of your computer that is split into several parts. So like your brain has two hemispheres, right? You have left and right. So your computer might have, for example, two processors inside. So two cores, my apologies. One processor, but two cores. That's what originally people introduced, but then they noticed that you can actually get 4 cores, 8 cores, and so on. So they decided to increase the amount of cores. Because what is happening now is that each core is working heavily on particular task. So if you have 16 cores on your machine, then it means you technically can work on 16 different tasks, and they're not overlapping each other. They're not conflicting for resources. So it becomes efficient to some extent. So your computers most likely have from 2 maybe to 4 cores, most likely at most, because right now you can go and buy maybe 16 cores processor for your desktop. You pay a hefty amount for it, but you do get maybe 16 cores. Yes?
Is the same core as a node?
No. And that's a good question. So when you have a laptop, let's say your laptop has, let's say 4 cores. In fact, it has 2 cores, but it looks like it's 4 cores, which is fine. I will explain. So let's say your computer has 4 cores, and you have this computer. We will call this a node. So this computer is directly yours. Your neighbor, your colleague cannot use it at the same time as you do, right? So we will call this a node with, let's say, 4 cores.
Okay.
And on our computer, when you log in, Supercomputer, you can request multiple of these laptops. So it's like you have a stack of laptops where you can work on them. Each of them has 40 cores. So if your computer has 4 cores, and you can buy maybe right now 16 cores for your desktop, we offer you 40 cores in each computer at the same time. And the difference between other systems of general purpose clusters is that you can actually specify how many cores you want. You can say, I want 8 cores, and you will be given 8 cores. You can do whatever you want with it. But on our system, you don't really request the cores, you request a node. So I'm saying, I need 3 laptops. So you will be given 3 laptops, 40 cores each. So you will get 120 cores, and it's your responsibility to make full use of it. So clearly, if you requested a resource, you want to use it. You wouldn't want to waste it. So we have on the system a window that allows you to work with this node up to 24 hours. So if you need to do the calculations for longer period, you need to find a way, and we can discuss this, how you can increase this window. So 24 hours is the maximum that you can get. So if you request in several nodes for this time being, you need to make sure that you're using the maximum out of it. So this is large parallel cluster, and this is Niagara. Also, the difference is that we do not provide GPU resources, so graphical user interface. Who knows? Sorry, graphical processing unit. Who knows what GPU is? Okay. So for those of you who maybe are not familiar, if you like playing games, that's what you probably have in your computer. So in order to play a very high performance game, you need a good graphics card. You usually pay a lot to get this graphics card. And that's what originally the purpose of it was years ago. But then people discovered actually that all it does, this particular graphics card, it just does a lot of matrix multiplications, because that's what you use in graphics when you play games. And they noticed that in the modern world, when people work a lot with neural networks and machine learning, all it does is also multiplying matrices, lots of them, millions of operations. And this graphical GPU, graphical process unit, is much better at multiplying matrices than CPU, than your processor. So nowadays there is a huge demand for this graphical video cards, simply because people want to multiply a lot of matrices, much more than it was a long time ago. So general purpose clusters offer you this hardware. We don't so far, so we might add some of them, but right now we asked researchers, those who work on our computer, and most of them voted that they don't really need right now GPUs and would rather have more cores to work with versus video cards. So I think I maybe talked about supercomputers before I actually showed you, but this is how this supercomputer looks like. That's what we host. We also have a couple of smaller clusters available. We have BlueGenQ, which is an older system, and its life is coming to an end. And we also have several other clusters where you can get access if you work with industry, for example. So as you can see, from your standpoint, you have a laptop. So if you stack laptops one on top of another and you put it like in a closet, that's what we call the rack. And these are basically like closets stacked together, and that's what we call a supercomputer. So it's just a fancy way to describe lots of different computers that connected together at the most optimal way to provide you the fastest communication between you. So why is it important? Well, you all connected over Wi-Fi, for example, and it provides some limitations, because when you just download a movie from the internet or a video, it's not a big deal. You can wait 5 minutes. But our researchers generate terabytes and petabytes of data, meaning that it will take days to, let's say, download it. So that's why we have to provide with much faster interfaces to be able to connect between these computers and also between our whole system and your computers as well, so you can download and upload it. So SciNet is the basically organization that runs the computer. We maintain it, making sure that researchers have access to it. But we don't just provide the support to the users. We also train and help the researchers to be more efficient. Because what is happening is that people come to us from different fields: biology, chemistry, not necessarily computer science or mathematics. So not everyone is familiar how to take their code that is running quite okay on their computer and suddenly make it parallel for thousands of cores, because not every software actually lets you do that. So sometimes you have to do the work. And even if the software does it for you, you still need to know how to run it, because it usually requires certain parameters to tweak, because software just assumes that you're running on your computer and you're not running on some supercomputer with thousands of cores, because this is a more unique situation than just somebody's running on their lab computer. Sorry. So it requires some knowledge and understanding what is happening, why your software is actually running slower in parallel, because that also could be a case. And we are teaching researchers how to adapt to this large, massive scale system. And throughout the years, we found out that researchers that are not maybe in computer science and engineering, they're curious to learn more about different programming languages, because that's what is getting more popular in their field. And their supervisor is basically saying, you know what, there is this wonderful programming language R. We would need you to learn it. You come to us and we offer you some courses. Actually, some of them are actually for credit at the University of Toronto. And you can get also a certificate from us stating that, yes, you completed something, and we offer several certificates. And it will verify your knowledge of certain languages. So we offer courses in C, C++, Fortran, R, Python, CUDA. Today, so for those of you who maybe came a little later, we have 2 more courses actually. It's Intro to Think Linux, and we have a meeting where I think somebody is going to give a speech. You can check our website. So everything that we teach, we post online on this website, so you can always just register and come. Everything is free. You don't have to pay a penny to come here, and we are happy to share our knowledge with you. So we offer courses, as I mentioned, under graduate courses for scientific computer data analysis and biostatistics. So one of these courses is in the Scarborough campus, one is here at the medical science building, and one of them is right here with physics department. So we, being in HPC, high performance computing company, basically consortium, focus of course on helping you to parallelize your computing, but we also noticed a very high demand for machine learning. It's a very popular nowadays way to handle your lots of data. So we offer several courses on machine learning and artificial intelligence. Very soon, maybe in a week or something like that, one of my colleague will teach neural networks. So if you're interested, just check the website. It will be a very nice course. I think 6 weeks, something like that. On top of that, this summer we organize a summer school for several days. We will be offering every day, full day lectures on different subjects. In computing, we will have several streams. So those of you who are maybe more into bioinformatics, you will find something interesting for you. Also machine learning, parallel computing, everything will be there. You can check our website. We're working on the schedule particularly, and you can register and attend. It will be somewhere here in the downtown area. Additionally to that, we organize also, well, we help to organize international summer school. This year is going to be in Japan, and you have to apply to get to go there. Maybe next year you can keep an eye on it. SciNet actually sponsors, I think, 10 or 11 students to go there from Canada. So there are many opportunities available for you to increase your knowledge in parallel computing, and SciNet is very happy to always help you with that. So again, the websites are on the slides, and this is usually the latest resource you can check for any courses available. So, but even if you forget about website and the only access you have is the email, just send us an email to support@SciNet, and we have a team of my colleagues that will answer any of your questions. If you have any questions about your research, we are happy to share our knowledge. Chances are the problems you're already experiencing, we already solved, because we have many people writing to us, this thing doesn't work. We already probably know the answer. So if not, we will come up with a solution based on our knowledge. Together with you, we will work to help you graduate and maybe write a paper or whatever you're working on. So I mentioned several times our team. So these are basically people that work. Some of us focus on software. Some of us focus more on hardware. Some people just work on both sides. So when you write us email, most likely you will see somebody from the left. So, well, if I haven't introduced myself, my name is Alexey Fedoseev. So Ramses is here as well. So if you have any questions, please ask. I'll be happy to help you. So now I keep talking about the supercomputer, and that's time to introduce what exactly we have. And we have 1,500 laptops stacked together. So each of you has a laptop. Well, we have 1,500 of them, one on top of another. We call them nodes, and each of them has 40 cores. So it totals to 60,000 cores that are available to you. Well, chances are you don't really need 60 cores, but very often people use thousands of cores. Depends on the problem. But even if you just want one node, having this resource with 40 cores is very helpful because it really speeds up your calculations. What is interesting is that each core on our system is probably slower than the core in your computer. Yeah, we have the newer cores, so newer, like the latest cores, and most likely it's very fast. But we're not looking to get the best performance out of one core. Because yes, you can get maybe 12 cores right now, and they will be fast. They will be faster in maybe hours, or at least in a couple of months if you get something newer. But we provide so many of them that it doesn't really matter how well it performs on one core, because you're looking to get the massive boost out of the parallelization, at particular for one thread, for one core. Because if that's what you're looking, probably supercomputer is not the best place to go with your research. So additional to that, since we have so many cores, we also provide you with lots of memory. So your computer has memory to store your intermediate calculations. And we provide around 200 gigabytes on each node, which is a lot, but it also could be not a lot depending on what kind of software you're running, because usually you assume that every core requires so much memory, and if you're using 40 cores, well, you have to multiply it by 40. You can actually run out of memory. That happens, not very often, but it does. And it's still a lot. However, other systems, they provide, I think, even larger nodes, but they don't provide many of them. So they might have 5 nodes, and if you're really experiencing the problem, the first thing is, for example, adjust your code, maybe because there is a memory leak or something to easily could be fixed. But if it's not the case and it's a commercial software, yeah, sometimes there's an option is to go to another system and use their resources. That's totally fine. Once you have access to one system, you have access to all the systems. Again, it's for free. For research, it's, I think, incredible opportunity. And Niagara is the #1 supercomputer in Canada, the most powerful computer currently. As you can imagine, the technology, of course, is being updated all the time, but so far Niagara is the largest, and we constantly looking to increase our performance. So for those of you who run Linux, you will be familiar with the system. For those of you who run Windows, we, as you already know, do not provide any Windows systems. We will run Linux. So if you work on Mac, you wouldn't really notice the difference if you're familiar with the terminal, or you will get familiar with the terminal. If you're on Windows, you need to get certain software, like, as I mentioned, Mobile Xtorm, and today we will be talking about it later in other courses. So if you have time, just drop by, and maybe you will learn something new. The way it's connected is also not trivial, because you have, if you think of multiple laptops, like if you will just stack the laptops here, one on top of another, how would you connect it? Because every laptop has to have access to the other laptop in order to connect it into one system. So it's not trivial because of the current limitation of this hardware. So we provide a particular way to set it up, and it's very fast. So you shouldn't worry about the connection between your different nodes. Of course, as you might be aware, and if you're not, then the interesting thing when you do computing, high performance computing, your processor could be very, very fast, but usually the bottleneck, the slowest part, is that when you start writing your calculations onto the hard drive. So this is the slowest part, and we provide the parallel system, which is much faster than the drives that you have, because it's a proprietary system, and it provides you parallel access from different nodes to the same hard drive. And you can think of it if two computers trying to access one external drive, and what if one of you is writing there and the other one is reading? How would you handle this? So this system takes care of it, and it's a complicated system. You just need to know that it's much faster, but it also requires you to be careful, because this is the thing that everybody shares, and if somebody is, let's say, slowing down the system by doing something wrong, it will affect everyone. So that's why you need to come to us, and we will tell you how to improve your code. It's absolutely free. Just shoot us an email, and we will explain anything that is in our capacity. So as I mentioned before, getting an account with Compute Canada is free. The way it works is that you need a supervisor, a PI, which stands for Principal Investigator. You can think of it as just a supervisor, somebody already having an account, professor maybe. All they need to do is basically vouch for you, saying that, yeah, this person is trustworthy. If you do some research under a supervisor, it's probably the case already. And if the first supervisor has an account with us, well, with Compute Canada, the supervisor just applies, and it takes a couple of days, maybe even less, to approve it. Once you have a Compute Canada account, you need to apply for a SciNet account. It's just to work with Niagara. It's, again, just another click. You just follow the link, just click apply. It's very simple. The whole process is basically fill the form and click the button. Very simple. And in a couple of days, you will have access to the largest computer in Canada. Do you have any questions so far about the process? Okay. So if you have any questions, just raise your hand, and we're here very hands-on. If you, yes, go ahead.
One question about the software. For instance, does Mathematica run on that machine?
Mathematica, I think, is it proprietary?
Yeah.
So,
no.
so we will talk about proprietary commercial software,
Yeah.
but the answer is no. But if you have the software with a license, you bought the license, we can help you set it up so you can work on it.
So that's possible that I've got a license and you run it on.
There is a possibility, but sometimes there are better ways to do that. With the commercial software, it's better just to talk to us directly, and we will tell you is there an alternative or how to set up the system. Okay. So now you see some commands. So this is what you type in the terminal. So if you have Windows, it will be MobaXterm. For example, you install the software. Here it says MobaXterm. That's how you spell it. So if you need to access Supercomputer or any remote computer, you just need to download this on Windows. If you're on Linux on Mac, you already have terminal. And that's what you need to type there, SSH, and then your username at niagarascinet.ca. Both links will work. So what does it basically do? It uses a secure connection that establishes the connection between your machine and the remote machine. And this command has the flag -y. So this is called a flag. Basically, it's like if you have a Windows software or a Mac software, you go to this preferences or settings and you check mark some particular option. The way you work with commands in a terminal in Linux is that you specify flags. It's like putting a check mark, but instead of putting a check mark, you just type, let's say, -y, and it means something to the command. you learn very fast because you usually use them all the time, or you create an alias for them. And this one will specify that, for example, I would like to use graphical interface on Niagara, which basically means that Niagara doesn't have any interface. It just doesn't have any GUI, graphical user interface, none whatsoever. But it will let you run it on your computer through certain tunnels. The thing is that it might be a little bit slow depending on your connection, because it's basically meaning that your window that you are working with, if it's, let's say, some visualization, is being transferred to your computer over the internet. It's not running locally on your computer. So it could be a little bit slow and maybe not the most beautiful, but it's a way to at least view something if you need it. The case usually is that just download your data back on your computer and use all the tools available on your computer to view it. You usually have much better tools to view it on your local Mac or Windows machine than on a remote machine. So the whole purpose is not to view, it's to generate lots of data, analysis, research, whatever you're doing, transfer back to the computer and then view it using your tools. So once you run this command, it will ask you for a password. You can set up a password-less connection, meaning that you can set up a secure key that every time you run this command, it will just verify that this computer is allowed to connect to the other machine, and it will let you without the password. So it's possible to set it up. There are many guides. If you have a question, ask us, we will help you. But once you run this command, you enter your password, you will be transferred to a remote machine. So now in every command you ran, you're actually running on the machine somewhere else. It's not on your computer anymore. And you can do lots of things. Can't say anything that you want, but basically most of the things that you want on the remote machine. But still, you're not on the supercomputer. You are on the login node. And yes, we will talk more about it, the login nodes and compute nodes and what are they made for. But so far, you can think of it that you're already on the remote machine and you can run the commands. So now, the interesting thing, that supercomputer works a little different than your computer. Yes, it's the same computer, but since, let's say, all of you connect at the same time to the supercomputer, even if it has 60,000 cores, what if one of you requests 20,000 and one of you requests 40,000 by mistake, or maybe intentionally, and we kind of already out of resources and you still have hundreds of you connecting, how would you manage to do this at the same time so everybody gets their resource? So people came up with the software called a scheduler, meaning that you don't really, when you run a command on a supercomputer, when you want to run your code on a supercomputer, you're not really running it at the same time. What you do is that you're creating a script saying, I want to do that. You list what you want to do, the commands that you're going to run. And you submit it to the computer. The computer will take care of it when it's ready. So basically, the scheduler, this system, will look for a slot for the time that you requested. Let's say you just need an hour. That's totally fine. You can work a short job, but maybe it needs just lots of resources, but it's short still, because on your computer it might take a week, but with thousands of cores, it might take an hour. That's totally fine. Or you're running 24 hours. So it needs to, the scheduler, the software needs to find a slot available. It will put you there, and you would need to wait a little bit for this script to run. This is called a job. So basically, you submit in a job, which is a script. And how long you have to wait? Well, it depends. If you, let's say, new to the system and you submit a job for 15 minutes, it's a minimum requirement that we have. You have to submit a job at least 15 minutes. It's quite easy to find a spot between the jobs with 15 minutes window. So your job most likely will run basically very fast. Maybe not instantly, but 5 minutes, 10 minutes. But if you start using system a lot, let's say you do a lot of calculations, hours, now system lowers your priority a little bit to let other people who maybe haven't run it. So it tries to balance it. So you would need to wait a little longer. Some people use a lot of system, and they might need to wait days. So every time you submit a job, you have to remember that you have a resource that you using, and just don't submit a big job if you're not even sure what it's doing. And we will talk about the way you should structure the pipeline, how to get to this final calculation more in depth. So that's what it's called, a batch job. And I will be using maybe this terms interchangeable with something simpler. If you feel a little bit confused and I'm using terms that you're still not accustomed to, just raise your hand and we will remind you, okay? So just feel comfortable, ask any questions. Me or Ramses, we will definitely help you, okay? So, storage. So when you work on your computer, let's say on Windows, you have this disk C, disk D, and it has different purposes. Sometimes you want to just store your movies on a hard drive, right? And you just connect it when you need it. So different purpose. We have also storages that have different purposes. Once you log in, you type SSH and your username and where you want to connect, you will be on a home file system. So your home is like your user space and your computer. Okay, I can't say how it's called in Windows, but let's say you log in and you have your videos, audios, music, you have these folders already created for you, you have downloads, that's what the basic stuff you're working with. So this is your home folder. Okay, when you connect to Niagara, you wouldn't get like downloads and movies and music. You will get basically nothing. You will get an empty space available for you. It's about 100 gigabytes. So it's big and it's not big. It depends what you're doing. It's good to start. And the way Linux file system is structured is a little different than a Windows system. I'm talking about right now Windows because if you're on Linux or Mac, you most likely know the way the system works. If not, ask us a question. We'll explain it. But for Windows users, you have, for example, C drive, and then you have different folders. Here, you have this first slash. So if you can see, it says here /home/g/group name. So every slash basically means click on a folder and enter the folder. So the very first slash means it's disk C. Like think of it as just your basic C drive. I think C is, well, it used to be the letter that Windows gave like to the first drive available. So basically the first slash is like you go into the C drive and you click there and you see all the contents. We will call this a root folder, so like the very basic one. And then once you start clicking, let's say program files, you click program files. So in our system, it will be /program files, and then you click something else, it will be / something else, different folders. So in order to get to a folder on your computer, you do a lot of clicking, right? You click on one folder, then inside there is another folder, another folder. It's a tree basically. So the way you work on Linux is that you specify a path. It uniquely identifies your location. So that's how you work. So every folder here is like clicking on a folder. So your home space is located under a particular group name. So as I mentioned before, you need a principal investigator, a supervisor. So this supervisor gets a group. And all your colleagues that maybe work in the same lab, you will be under this particular group of the principal investigator. And that's what group name stands here for your private principal investigator group. It's the previous G is just as an example because we have many of them, and in order to sort them out, we have sorted by letter. So you don't need to worry about it. You don't have to type this long name in at any time, because we provide you with shortcuts. So every time you type $home, it will imply your home folder, home directory. On Linux systems, you also have tilde sign. That's what you usually do. I never type home. It's just tilde is always a shortcut, and it's certainly much faster. But if you somehow want to type it, maybe in your scripts, that it's available. Now, so this is your like disk C, let's say, storage type, where you store your downloads, your movies, your everyday activities. Now, you have another file storage available to you right away. It's called Scratch. And that's where you start from the scratch. You basically have nothing there. It's much larger. It's, I think, like 25 terabytes for the whole group. And what it's made for is that once you run your calculations, it generated 2 terabytes of data. You waited several, maybe hours to run it, and then you waited 10 hours to produce all these calculations. You would put it on a Scratch, on this file system. And the thing about it is a temporary storage. So your home storage is permanent. Whatever you put there stays there. This is your everyday storage. Scratch is where you put the results of your calculations, and then, which will naturally would imply that you go through your calculations and you sort them out. You select good calculations, you maybe discard those that are useless, and then you would like to put it, let's say, on your home back. So your calculations could output lots of garbage that you want to get rid of. Select those that are important and put in your home. If home is not enough, we also provide project space. We'll talk about it later. And you can store much higher volumes on your project space as well. So we have this several file system. Each of them has its own purpose. So you have to remember this purpose. And the Scratch system, if you stored some files and you haven't accessed them for 2 months, you haven't read them, you haven't done anything to them, you haven't copied them, you will get a notice that you haven't accessed these particular files for 2 months. Please look through them, because if you haven't accessed them for 2 months, most likely it's garbage anyway. You don't really want them, and we will delete them in 2 months. So if you got a notice and you haven't done anything for several days, you get, like, I think 2 week notice. And if you haven't read them, you haven't copied, we assume that you don't want them anymore. They will be gone. So use Scratch for something that you can actually reproduce your calculations. So it's not critical to lose it. Your home is permanent. So whatever you put there stays there. It's backed up. We back it up quite frequently. So it means if you accidentally deleted something from your home, shoot us an email, and one of our colleagues will just restore. We have very often like 2 terabytes of data was removed or something. So we will restore it, because accidentally you can remove something. Linux is, it's an interesting system to learn. It doesn't really have a trash. You know how on Windows and Mac you have trash, you can delete there, then you change your mind, you put it back. There is no trash in Linux. Once you type that I want to remove something, it's gone. It doesn't ask you the second time, it just removes it. So you have to be careful. It's very easy to overwrite the file. You know how in Windows, let's say, it says, oh, there's already a file with the same file name, what you want to do. It doesn't ask Linux, it just overwrites. So if you copied something and the file was there, it's gone. So we back it up, ask us, and we most likely have a copy of it. Okay, it's not every hour, it's maybe a couple of days, but most likely we have a copy for you. So Scratch also has a link, an alias to it. Please use it all the time. You don't need to type Scratch G group name and so on at all. So here's an example. It's actually Ramses's account. And as you can see, we all belong to the group SciNet because we work together, right? So we're kind of under the same group. It will be the same for you under maybe in one lab. And that's how you can navigate. For example, if you type cd, which is a command to change directory, you can think of it cd as like click on a folder. It will just go into this folder. So cd and then alias Scratch. it will jump into this folder. So it's like having favorites in your, let's say, computer, where you just have access to downloads, documents, just click there and you go there right away. Of course, if you access certain locations very often, you don't want to type the name all the time, so it's a good idea to just create an alias. You have any questions so far? So project space. So some principal investigators, they have big groups, and what we offer by default is too small for them. So some people consider 25 terabytes is small because they generate petabytes of data. And they can apply for rack allocation. It's being held like once a year. You apply for it. You say, I need so many resources, so much storage, CPUs. That's what I'm planning on doing. You need to justify your usage. Well, your PI would be probably doing that, but chances are that you will end up supplying the material and the foundation. Why is it important? So once the allocation has been granted, so some committee will look through it. Is it reasonable? Are you asking too much? Is your research actually needed? Because some people just request because just they want, and it doesn't really mean that they're going to use it, because we look at the track record, and if the person keeps requesting like thousands of cores and they're using only 10, well, what's the purpose of giving? Because it means we have to take from someone else who actually is using the system. So we're trying to be fair to some extent, but again, we're not particularly too critical, but your PI should be reasonable. So it's normal to a little overestimate if you need just a little more, but not too much. So project is another space that is backed up. So when you think of something that is backed up and it's large, it means that it's usually meant for something that you want to store there permanently, kind of, for a long time. You don't want to write it and delete it and do a lot of turnover of the material there, because if you do, you will get an email from us saying that, why are you doing that? Because it really loads our backup system. Because if you uploaded a file there and then you start moving it around in the different folders constantly, it loads the backup system, because now we have 10 copies of the same file in the system, and there is no benefit for you, there is no benefit for us. So if you generated something and you need to read it while you're doing the job, just copy there, put it there, and just leave it there. If you need to delete it, that's fine, but sometimes we see people copy 10 petabytes of data and then they delete it the next day. That's not a good way of using the resource. Okay, so we're giving these resources for you for free, so please just follow the guidelines. Nothing difficult. Each system has its own purpose. Burst buffer. Okay, our parallel system, as I mentioned before, is much faster. Our storage is much faster than what you have on your computers, but it has its own limitation, meaning that it doesn't like lots of small files. So let's say your program generates logs. So basically you log in whatever outputs of your software code is, and you generate like 10 kilobytes each file, and you generate like millions of them. You think, well, not a big deal. Well, it is a big deal, because you're not wasting space. You are basically slowing down the performance of the system, because it doesn't like small files. What you need to do is you need to bundle all the small files into one big file. Let's say you just archive it in the memory. And we'll talk about it a little more in depth. Maybe it's a good time to talk it right now, actually. So you need to bundle it into one big file, and that's what you're writing. It will be much faster for you and for everybody else. Okay? So when your job is running, it's like you have your laptop and nobody else can have it. But the point is that the file system is shared. So it's like you have an external drive to your computer, but you have kind of other people using it at the same time connected to it. So it's your computer, but the storage is shared. So if somebody is writing right now a huge movie on this external drive, it slows down everyone. So our system is fine with huge movies, not movies, with huge data, let's say huge archives. It will be fast, it will not slow everyone else. But if you start writing lots of small files, like tiny files and millions of them, because it's very easy, it's just a command, not a big deal, it will slow down everyone. And you wouldn't want to affect, first of all, yourself and your colleagues, because it will slow down your performance. So you need to look if your system generates a lot of I/O, which means input-output. It's right into the hard drive. And some software, like commercial software, well, nothing you can do. It's just the way it is. Or you got some software, you don't really know what it's doing. So basically, you cannot change the way the system works, the way the software works. You need to write a lot on the disk. And in this situation, we provide an additional storage system on demand. It's called burst buffer. It's a solid state drives, lots of them together. It's not as big, of course, as other systems, but it's very fast. And I think modern laptops have this so this storage type, SSD. It's like a flash drive, basically. It's very fast. It's faster than spinning disks. And it's very suitable for writing a lot of small files. So if you really need it, you can write us an email, and this is a resource that's on demand. So once you need it, and you can actually explain why you need it, we can grant you access. It's a temporary storage, so once you wrote all your files, you have about 2 days to retrieve it. So please use it, put it somewhere else, or archive it together in one like big file and put it aside. And then in a couple of days, it will be deleted. So we have other storage type. So we already talked about home, scratch, project, burst buffer. Do you have any questions so far before we proceed? Another storage type we have is the archive. So your job, your script generated lots of data, let's say petabytes of data. And you set aside the data that you need to continue research. And you would put it on project. That's what it's meant for. Your jobs will be reading. They're not going to write on project. They will going to read it. So you generated the data to continue your analysis. And that's fine. You generated more data. And now you have data that you don't really need. Let's say you prepared it for later, and you're not going to touch it for a couple of months. You're not going to read it. You're not going to change it. It's just there for later. You're not going to access it. And that's what archive storage is meant for. You can archive it in a particular way and store it aside. This is a very slow system. It's not intended to be fast, simply because you're putting it aside. You're not going to access, so there is no need to be fast. It's very slow compared to the other storages that we provide, but you can store a lot. It uses a very old technology, tapes. It's like an audio cassette, basically. But each cassette is huge. It's like 6 terabytes or something like that. But in order to, if you know what its audio cassette is, in order to get to a track, you need to rewind it. So that's what you need to do with a tape. And if you have 6 terabytes of data, you need to rewind a lot. So it might require some time to get to your data, retrieve it, and put it on a tape. But you can put a lot of it there. You can apply for more archive space under this allocation, or your principal investigator can do that. So this is a slow storage. It's meant just to put it there and leave it there for a while and retrieve it once you need it. And now we're coming to probably the most important place that you're going to use, the RAM disk. So your computers have memory. It's called RAM, random access memory. That's where all your calculations are being performed. It's the fastest part in your computer. All of you have RAM, 16 gigabytes, 8 gigabytes, depends on your system. Obviously, the more you have, usually the more you can do. Your system takes a little bit, your calculations takes a little bit, if you keep playing a game, it takes a little bit, maybe a lot actually. So the more RAM disk you have, RAM space you have, the more you can do at the same time. So now you could imagine if you have 40 processes running at the same time, each of them is using certain amount of space. You need lots of memory to fit it all together. So we have about 200 gigabytes of memory available on each node. So you can think of it as a laptop with 40 cores and 200 gigabytes of memory. Sounds amazing to me. And up to 70% of this RAM, you can actually use as storage. So you might not be familiar, but you can take a RAM, a memory of your computer and use it as storage. You literally can copy files there and delete it from there and do whatever you want. The tricky thing is that it's temporary, meaning that, yeah, you can put file there, but if you reboot your computer, it's gone. So it's not permanent, it's temporary, but it's extremely fast. So what makes sense, if your, for example, software generate lots of small files, put it on this RAM disk. We provide an easy shortcut to do that. You would just basically say, well, instead of putting on disk C, we will put it on disk E. And the system automatically will put it in the memory. So it's very easy, and you don't have to put it on the system because it's faster to read, faster to write. And once your job is done, you can bundle it together into, let's say, archive, just zip it, and put it on the hard drive. That will be much faster instead of writing lots of file on the file system and then doing all these operations on the file system. So do this in the memory. Up to 70% is available. The tricky thing is that if your software uses a lot of memory just by itself, it reads, let's say, huge files, it performs some copying of it, modifications of it, it might just eat a lot of space by itself. So you need to be careful that you might not have enough space to write something, and you will be, of course, forced to write on the file system. So it's a trade-off. A good place to start is a file system in general, but if you see that the performance might be an issue, you want to make it faster, you can just try the memory. Okay, so keep in mind that it's available. So this is the fastest place to write and read. Any questions about file systems or access? Okay. So this is a short summary of what's available. So clearly when you buy a hard drive, it has certain limits. You cannot just squeeze more than you bought. If you bought 256 gigabyte hard drive, you cannot put 500 gigabytes of data there. So we provide you with the limits, quota. And as you can see, Scratch is 25 terabytes, which seems like a lot, until you wake up one morning and you figure out one of your colleagues actually filled it up completely and you have no space to write. Because we sometimes see that they're saying, well, it doesn't work. Well, it says that there is no space because somebody else filled it in. So you need to contact your colleague and say, you know what, I also need to do some work, and you just clean it up a little bit. But at the end of the day, no worries. If they did it and for 2 months they didn't do anything, it will be all wiped out anyway. So it's a temporary storage. So it basically summarizes the differences between them. So you have which one is temporary, which one is permanent, which one is backed up. What you have to keep in mind, and we get this question very often, I submitted a job and then I waited for 2 days and then it tells me that I have no access to read and write, it just failed the same time. What should I do? Well, the answer is you haven't tested it. You just submitted a job and you actually never tried to submit a short job, just to, like 15 minutes job, just to see, is it going to work? And in fact, it's not even actually the best way to do that. I'll describe how to do that in a better way. But what is happening is that your home folder, your home directory, is read-only once your job is running. You cannot write from your job to your home folder. Remember, your home folder is for stuff that you're working every day. Maybe you want to install software there, because you can install software in your home folder. We provide lots of packages installed for you already, but maybe you need just that package of just this version with this particular dependency, and we don't have it. The option is that you can write to us and we can install centrally, so you don't need to install it in your home folder. However, we will usually do that for software that's used by many people. Like if it's just for you, we can help you install it in your home folder. That's totally fine. So if you have any problems installing software, write us an email, we'll help you. Not many of you maybe installed software in Linux. It could be challenging, I have to agree with that, because it has lots of dependencies and they all have to be met before you can actually install anything. So if you don't understand, you get some weird messages, just send us an email, we'll help you to install it, okay? So that's what you usually have on home. You have your maybe configuration files. You're not going to change them while the job is running. You have your software, so it's going to use this software but not going to change it. So anything that is going to change has to be on Scratch or project, but Scratch most likely. Project is not meant to be changed a lot. So that's why the last column says read-only home. You need to remember that. As we get this question very often, because people just, like, I'm very grateful that you came to us, because I will probably answer lots of questions that you will have initially. If people just jump on the system, they never read our wiki. We have a very extensive wiki page that describes basically how to start, quick start. You get this basically silly question, because if you get an error that it's read-only, it's just because you haven't read anything. You haven't listened to us. It's explicitly stated that you cannot write on home folder. Okay, not a big deal. You learn, right? But if you have opportunity to not waste 3 days to wait in queue to run the job and then figure out that you actually cannot write on home. So we get these questions sometimes, and it's we just wish people came to us earlier and we just explain them. Okay, so yeah, backup. By backup, basically we mean that the changes that happened from the previous backup doesn't really mean anything to you. You just ask us, do you have this file? I deleted it. We check, we verify. If we have it, most likely we have it, we will restore it. Only for home and project. Okay, just keep it in mind. So Scratch is not backed up. So whatever you lose on Scratch, it's gone. Yeah. Okay, so moving data. Since people generate lots of data, petabytes of data, if you will use Wi-Fi to transfer it, it will take forever. So moreover, we limit the ability to use login nodes. Remember, login node is when you type that you connect to Niagara, you're on a login node. It's like a welcome computer. It's not particularly meant to run any jobs. It's just to greet you and let you get more familiar with the system. Maybe just figure out if your code actually is running, compile it. So it's not meant to run the jobs, huge jobs at all. If you do that, they will be terminated. And it will be terminated by the system, in fact. And even if we notice that, we will terminate them as well. We will write you an email, please kill your jobs, because it's not meant to run big jobs, simply because it shares between all of you. So if all of you connected to the login node and one of you start to, I don't know, run their huge job, taking all the cores, it affects performance for everyone else. And if somebody cannot just compile their code, because compilation also takes some resources. And obviously we don't want this to happen. We have several login nodes, and you will be directed to the least loaded, of course. But still, if you experience that problem, it means somebody else is doing something, and their job would be, their script will be killed quite fast. So that's the problem. We have a timeout on how long you can run anything on login node. And it also means when you transfer something, so you upload the data or you download it, it also has a limit of the same thing, because it's a command running. So you basically type a command, I want to download my stuff. And since it's a command, it will have the same limitations like any other command you're running. So if it's 10 minutes, it can only run 10 minutes. If it's 15 minutes, it's only 15 minutes. On average, you can transfer about 10 gigabytes in this window time frame. So if it's less than 10 gigabytes, you have time to do this on a login node. But if not, then we provide you with data mover nodes, meaning that if you need to transfer something greater than 10 gigabytes, you need to log in first to these nodes, and do this there. It's meant for transferring the data. It has higher connection actually to the world, so you will transfer your data faster and without interruption. Another system we're using is called Globus. It's a web interface, and if you have access to it, use it. It's convenient because very often we have users transferring from within the systems in Compute Canada, for example, from, remember I mentioned Supercomputer in Waterloo or in British Columbia, and you need to transfer it from there to Niagara, for example, or between the systems. You can just go to this web interface. You will say, well, I need to transfer this folder into here. You will see both folders on the same screen. Very convenient. It's just a matter of dragging the folder, and it will be scheduled. Well, you're not going to really wait for 100 terabytes to be transferred, although I guess you can watch it on the screen, but you will probably submit it and you will just go do your stuff, and in maybe a couple of hours, your data will be transferred and it's all good. So it's convenient. And also the archive space. Remember how I mentioned that you can store your things away for a long time? To archive, it could be referred by several names: HPSS, nearline storage. It's all the same thing. HPSS is its official name, but you can think of it as an archive. And you need to do some manipulations to archive it, but you do this kind of once in a couple of months. So we have a wiki page where we'll tell you how to do that exactly. You just copy the script, you change to your paths, you submit it. You don't really have to do a lot of thinking. So we on our wiki page, we give you lots of examples. All you have to do is just copy, tweak it to your particular command, and run it. Like, you don't have to come up with anything. Only we provide you with templates for most of the things. So software, as I mentioned before, we already have pre-installed lots of software. The commonly used software is there. Whatever you're using, most likely is there, if it's open source. So open source packages we can easily install, but as you can imagine, commercial software available that you have to pay, we can't really buy it for everyone because, limitations of licensing. But if you have your own license, you can come with it to the system, and there is a possibility that we can arrange it so you can run it. So if in this situation, just ask us and we'll tell you. So now you could imagine that each of you is running different software, and the software has dependencies because software uses other software to generate something, and this software might actually use other software. So there's lots of dependencies because people don't want to write the same thing over and over again. So people use existing software to improve their own software. And the thing is that one software is using one version of the package, another software using another version of the package. It's lots of software installed with different packages, with different versions. And how do you make it? Let's see here. How do you make it all convenient for everyone? Well, the software is there, but it's not accessible until you load a module. So the way supercomputers work is that you need to load the module, and the software suddenly becomes available to you. You don't have to install it. All you have to type module, load, and the name of the software. Very simple. And the software will be available to you to use. How would you know what's available? You can type command module spider. We use certain software that came up with this name, so we just need to remember. Module spider will show you all the software installed. And the way it works is that if the software needs a dependency, the dependency has to be loaded before you can actually load the software. So if suddenly, well, this is the example, for example, of module spider. It shows what's available. That's what we installed already for you. And these are commands that you can interact with the system to load the modules. There isn't need to memorize them. You will use them all the time, so you will just end up remembering it quite fast. Since we don't have that much time, I will be a little bit faster with slides, but I talked about most of contents of the slide already. So the software that we provide requires dependencies. So it's a bunch of software that has to be preloaded before you can actually access your package. And different packages, different versions, it's different architectures because all your computers are different. And some of you have different actually processors, different technologies. Some of them are faster, some are slower. It's a lot of things to handle at the same time. And since our system is new, actually the newest so far, it uses the latest technologies. We use also the latest optimizations available to the software to make it as fast as possible. And that's why when it was originally deployed, the system, we created our own software, installed it. But Compute Canada, remember this umbrella corporation, it provides you with software installed. It's called the software stack. So it's basically lots of software pre-installed for you. And you can access the same software that you can access on every other system. It's just on our system, you need to do one more step. You just need to load the command module load CC environment, Compute Canada environment. And it will give you access to everything you can get on other systems in Waterloo and British Columbia. So we provide 2 software stacks. It depends which one you want to use. By default, when you log in, you get our software stack that's optimized for Niagara system. It's up to you what to use. We usually work with our software stack, so if you have a question, we will install it into our Niagara software stack. But if you really want to use software stack from other systems, it's available there, nothing is lost. So what people do in order to load the software, they need to type module load, and then they need to write the package name. I noticed some of you are taking pictures. So these slides are available online. Are you familiar with that?
Yeah.
Like if you go to the educational website, you probably the way you registered. If you go under this Intro to SciNet link, probably will be the one of the top one, or it will go into archive after it's finished. It has a PDF, it's a file storage. Just click on it and it's the same slides. I downloaded from there. So nothing is lost. It's available for you, of course. But of course, feel free to take pictures if you want. So every time you log in and you use software, you have to load the module. So people came up with the solution that, well, why would I do that? I will just put it in one place that is being loaded every time I enter the system. It's a common place called bash rc file. It's in your home directory. It's hidden. You don't see that because you actually not supposed to change it unless you know what you're doing. So people discovered that and they figured out, well, I will put it there and it will be loaded every time. Do not do that. We have an extensive experience here running several systems, and very common, the problems that you're writing us about have something to do with that thing put in there. Like if you put in the module load command in your bash rc file, and in a couple of months you switch to other software and now it doesn't work, well, it's because you have a bunch of other softwares loaded that are actually conflicting with what you're doing right now. So once you put something there, you tend to forget that you have something else happening there. And from our experience, we know that we need to go and check this file and just remove it from there. But you wouldn't know because you're not having experiencing problem every day, and you wouldn't know where to start. And you might spend a couple of days trying to figure out the problem, which is in fact that you have other software conflicting with it. So just type module load the command. It's not a big deal. Just type it out. Moreover, when you load your job, when you submit a job to the cluster, you would need to type explicitly module load in a particular software. You have to. Okay, so you need to do this anyway. It's good to do this manually so you remember what you're doing. So I already talked about most of it. So this is an example, for example, how to load an OpenMPI module. So if you type module load OpenMPI, it gives an error because it says, I don't know what it is. Well, in fact, it's there. It's just you have to load the requirement first, the dependency. So you need to type module spider OpenMPI. It will go search for available OpenMPI modules. We have actually plenty of them installed. Once you specify module spider OpenMPI and then the particular version that you're interested in, it will actually give you the prerequisites. That's what you need to load. So it basically means that you have to first load, let's say, Intel module, and then you can load OpenMPI and it will be available to you. So if you try to run something and it says it's not found, it's probably there. It just needs to, you need to load dependencies. So remember to type module spider and the name of the software. It will give you all the information available, the version, and then it will give you dependencies. Dependencies must be loaded before you can run the software. Makes sense, right? So the command module list displays everything available. Right now, what you already loaded in your workspace. And clearly you can see that Niagara environment, our software stack is always loaded first, then your dependencies, and OpenMPI here is the latest, the latest module. So commercial software, as I mentioned before, people usually want to run MATLAB. MATLAB is just not a good software to run on a supercomputer in general. It's slow. You can compile it into faster code, and you have an option to run this particular compiled code. Again, you need licenses to do that. We cannot provide to each of you licenses that cost lots of dollars, but we do provide something that everybody can benefit from it. Intel, so we use Intel processors. Intel, as a company, supplies also the compilers that are optimized for Intel chips. It's usually faster, much faster than other compilers, but it's proprietary. You have to pay for it. So we do provide it because we obviously use an Intel software, hardware, and we provide Intel compilers, certain mathematical libraries, and debuggers. So we provide you with something that everybody can benefit. But if you're running particular, let's say MATLAB, you need to come up with your own license. And actually other systems, Graham and Cedar, they have MATLAB installed. All you need to do is supply your license. So that's available. But the better alternative is to use something open source, like Octave, for example, is basically a clone of MATLAB. Not all the functions, but try using open source software. So by far the most popular software right now is, of course, Python and R. It's used all over our system, of course, C++. So that's the commercial software that's available. What else is there? So again, if you have any questions, just send us an email. So when you have open source software, you usually need to compile it on Niagara. So you transfer the source code, and then you need to run a couple of commands. Again, if you're experiencing problems, you do not know how to compile, or you followed the guidelines, installation guidelines, and it doesn't work, something's like an error, just send us an email. We'll help you to resolve it. That's what we do every day. So this is an example, for example, how to compile with some optimization to get the best performance. So testing. So the way things should be tested is that once you unlock a node, you can run a very short test to see if you're actually job being parallelized. So you can check, is it taking 2 cores or 4 cores? Not more. There's a need to run on all the cores, because you're not just testing if it's actually picking up and it starts working. So it's normal if you use a couple of cores for like a couple of minutes just to see if it's going. But you want to make sure it's also working well for like more cores, 20, 40 cores. Login node has half of the cores that the rest of the cluster has. So it has 20 cores, where the cluster has 40 cores. And in order to get kind of one true node from the cluster for yourself, you can type a command, for example, debug job. If you just type debug job, you will be given one node from the cluster for an hour. It's more than enough to just test your job, run it for an hour to see if you get the performance you expect to get. you can monitor, for example, is it using all 40 cores? Are they all fully occupied? So if you watch the performance and it says 100% for all the cores, everything is running for an hour, perfect. You're using the best, the most of it for the most of the time. So keep in mind that you might see if the job is using all the cores, you will see like it's using 4,000%. The CPU is occupied, like the busy, what do you call it? The percentage wise, it's 4,000. It's basically 100% times 40. That's normal. It means it's fully occupied. Computer also nodes, the processors, we have enabled hyperthreading. Means, in fact, each physical core is accounted as two logical cores. So remember how I told you that your computer has actually two physical cores, but it actually shows like you have 4 cores. So what happens is that you can actually run 2 threads absolutely in parallel. They're not really competing with one another. And with hybrid threading enabled, you basically can run up to 80. You can use up to 80 cores, logical cores, on the system. But from what we saw, the speed up from 40 to 80, about maybe 10%, 5%. So it really depends on your code. 40 should give you lots, and if you think it's not enough and 80 gives you more, go ahead, use it. You will be accounted only for using 40 cores. So it's basically performance for free. So after you test it on a login node, so you get to this debug node where you have the full node, nobody is sharing with you. So login nodes are shared. So if somebody is starting to do something, you will see the performance drop down. Like it's shared resource, right? If somebody is writing or using a lot of CPU, you will see the degrading performance. On the debug node, it's completely yours. You can do whatever you want for an hour. You can request up to 4 nodes like that because you want to make sure that your communication between the nodes is working well. So sometimes you want to just 2. Let's say if you type debug node 2, you will get 2 nodes for 45 minutes. More than enough just to test and make sure that everything is running. And if you type debug node 4, I think you will get 4 nodes for 15 minutes. So it tries to kind of balance how much you get. Because at the end of the day, you just need to make sure that it's running. And then once you sure that everything is running well, you can submit your job to the cluster. Remember how you need to run the command. I think it's called as batch. That's the job script that you create. And this job will be running on the cluster, on the big 60,000 core cluster for as long as you request it. So maximum you can request it 24 hours. And remember that compute nodes, so the main cluster, doesn't have access to the internet. There is no need for it. You're not going to download something when you have only 24 hours. So pre-download anything, put it on a local storage, put it on a storage about home, scratch, and then access from the compute nodes. So,
Sorry.
Yes?
I have a question here.
Yeah.
Can one use more than 40 cores?
Yes, of course. So the idea is that one computer has 40 cores, but then you can request multiple computers.
And they work in parallel?
Yes,
Okay,
correct.
good.
You just need to make sure that one computer can talk to another computer. Because now it's like having 2 laptops. You need to know how to coordinate them. So the software can do this for you if you're using some advanced software. But if you're writing code yourself, you would need to find a way to communicate between these 2 computers. Because within one computer, it's one thing, but then you have memory between 2 computers. They have 2 different, let's say 2 different computers. They're connected, but they're different. So you have different ways, let's say MPI, message passing interface, where you can communicate between these 2 different computers. Let's say you have a matrix in the memory of this one, you want to transfer it to the memory of another computer. So there is a way around, of course, but you need to make sure that's where you use debug node, where you connected 2 or 3 different nodes to make sure that they're all completely loaded. Because sometimes we see people requested 20 computers, 20 nodes, but they only work on one. But the point is that they will be accounted for 20 computers. It's a waste of resources, right? So if they're wasting 20 nodes, it means somebody else could not get these 20 nodes. So you will get an email from us that, what are you doing? You requested so many nodes, but you're only using so much. Maybe just you didn't tweak the parameter. That's all that it is. It could be as simple as just changing the parameter. And speaking of parameters, this is just some terminology that our scheduling software uses. What I suggest you doing, this is just what I already told about hyperthreading, is that you go to our wiki page and you go to Quick Start. It's the very first page of Niagara, and you get the example. Just grab it from there, and you don't really need to change a lot. You just need to change how many nodes you want. The first parameter, as you can see here, it says nodes. So these are commands to our scheduling software. It knows what to do with that. So you specify here, I want 1 node, I want it for 1 hour, and some other parameters. And then you need to load the module, of course, and then you need to run your command. So that's what you submit into the cluster. And here you can request whatever you want, up to 24 hours in time frame, and as many nodes as you need. Well, the more you request, the longer you will wait. So the idea is that, well, my job will run maybe for an hour, but I will request 10 hours. Well, you will be waiting like you're going to use 10 hours. And why would you wait? There is no need for that, and you will be accounted for longer period. So the idea is that you estimate how long your job is going to run, and you add about maybe 10-20%. Don't ask for like twice, thrice more resources, just you think, well, just in case, because you will be waiting longer and you overuse your allocation. So here's basically short description of what each line does. The idea is that in the beginning you have the commands to the scheduling software, and after that you have commands that will be actually run. So remember, you need to load the software, the modules, and then you run the commands. So I will skip it. Just another example how to run the code. It's basically the same thing. We provide several commands to monitor your jobs because you're submitting it on a cluster, so you're not really watching them. Because, well, are you going to see 10 hours in front of the computer? No, you created a job, you submitted it, and then you went home and you're just relaxing and enjoying your time. Meanwhile, the computer is working. That's the whole purpose of the computer, to free your time. So just go through the commands, get the sense of it, submit a job, cancel it. You have all the opportunities to do that. There's not particularly to describe here because you just need to try it and you will see how to interact with them. So it's all about trying, trial and error. The idea is that once you get on the clusters, create a small job, let's say 15 minutes. You don't have to wait a lot, but you get to experience what it means to run the job, to cancel the job, to look at the performance, how it will be accounted. So there is no need to submit a 24-hour job and they wait long time, and actually the job might just fail because you specified something wrong. We also provide a monitoring tool which is very helpful. It's called my.SciNet. It's what we developed here. One of our colleagues did. If you log in here, you can see here is at sign in. If you use your credentials from the Complete Canada account, you will see. So this is overall the performance of the system. It's being used, for example, like at 89-99%. So it's very good. People are using the system very well. But once you log in, you see more about your job, its current state. The system queries it every 10 minutes. So you might get a little bit delayed result, but only by 10 minutes. So here it shows that it's running. It requested 2 nodes. So you will get about 160, sorry, not about it, but exactly 160 CPUs. Why? Because it accounts it with hyperthreading. So in fact, you get 40 physical cores, but with hyperthreading, it will be considered 160. But it doesn't mean you need to use all the 80, but you need to use 40 minimum. Make sure that using as much as you can. As you can see, it will be built by 480 cores. So here it will show you what actually nodes were allocated. So we have 1,500 nodes, and it will pick based on what's available. Let's say you've requested for 2 nodes, so 2 of these nodes will be given to you, to your script, for 1 hour. And it also tells you where it was launched from. Remember that you need to launch it from scratch. Well, and some other information. It also shows you the performance. So here's the graph to show you how it performs during its running time. If you see that it's like basically not doing anything, that's a sign that something's wrong with your job. So here it's a short job, it's an hour, so it's only a couple of points were captured. But if you have 24 hours, you get lots of information, of course, to work with. So what you want to see 100%. Okay, 100%, it means all the cores are being used. It accounts for multiple cores, so 100% means like 100% of utilization of the node. So it's basically 4,000 in terms of monitoring tools if you directly look at in the terminal. So it also records a script that was submitted, so you can come back and look what you submitted. Again, we already talked about tips. One more tip I need to tell you is that try writing the binary format. It's much faster than ASCII code. So try not to write in plain text. So you can write a matrix basically using spaces and like new lines, like number by number, so you can actually view it. But chances are if you have like 10 million by 10 million matrix, you would never look physically on it, like physically read it. So it's best just to save it as a binary. There are ways to do that in every language. So just keep it in mind. If you need to save something, save it in binary. It will save you space and time. It's much faster to write it in binary code. So we already talked about performance with many small files. So, that's basically it. Here are the links. Pay attention to the second one. It's a quick start. Basically, it's a summary, and all the templates are given there. So it's the best way to start. Just read through it. It will repeat probably most of what I said right now, but it will give you the templates with the right commands. Keep in mind, the last thing I think I want to notice is that here you see the second command to the scheduler. It says end tasks 80. What we notice, people forget that if they request more nodes, let's say they request 3 nodes, well, you need to change this parameter. You need to multiply it. So now it will be 40 times 3. People forget about it. So use, instead of end tasks, use this command, end tasks per node, which basically you put end tasks per node means 40, and now whatever amount of nodes you request, it will be automatically multiplied. So we notice that people request more nodes, but they forget to change end tasks. They need to do this appropriately. And in order to avoid this, just use end tasks per node, just set it to 40, and then you can change the amount of nodes, and it will automatically adjust in the system. One more thing, if you need to run MPI job, MPI run is the command. You don't need to specify the number of processes because it'll be automatically taken from the scheduler. You might need to specify it if it's unique to your situation, or you might play with the parameters. So overall, go to the wiki page. It will have, I think, end tasks per node, so you will get a proper script to submit. And our wiki also has other explanations about like archive storage and everything else. Do you have any other questions? Yeah?
So what if our job is, it runs longer than more than 24 hours?
So your job cannot run longer. So if you, let's say, request longer, you will not be allowed, I think, to submit it. But regardless, your job will be killed. So it will be automatically just killed after 24 hours and a couple of seconds. So once it hits this 24-hour limit, it will be killed. So what happens if you need to run longer than 24 hours? Sometimes you need like 48 hours. Most likely your job is generating some intermediate data. Save it on the hard drive, on the file system, and then make it 24 hours. And the next time you run your job, just read this intermediate data and continue from there. Lots of software provides you with so-called checkpointing, meaning it will actually write it and it will just pick up where it stopped last time. So it's very convenient, and that's the way to do that if you need to run longer jobs. Okay. Any other question? Yeah.
Suppose I give like 2 hours, but the job takes 3 hours. Because sometimes we guess how long it's going to take.
The job will be killed at the time frame that you requested. So if it takes longer, well, again, you need to be careful with your estimations. So if you figure out that it was killed, you request more time, of course. But usually people have kind of a sense of how long it's going to run. So if you have the sense about 3 hours, request it, let's say 4 hours, 3 hours and a half, 3.5 hours. So it covers the time frame. But if you surely see that the job is being killed before, it's clearly it's not enough time. But it doesn't mean that the job maybe needs more time. It's just maybe it's hanging in a memory. Something wrong with the code. So it's also possible. You just need to come back and look, is it actually running, or is it just sitting there and like a zombie process that does nothing? Any other questions?
So,
Yeah.
So how much space under the Scratch directory for each user? 25 terabytes.
It's shared between the group,
Oh.
but you get quite a lot. I can say how much. How much is the per user?
For what?
Scratch.
Well, it's not a quota. It's a limit, but I think it's 25 terabytes.
Okay, but it's for every the group.
Every user, I think.
Or for user.
Yeah.
Okay, so maybe it's actually for a user.
Yeah. The trouble with it is, and why it's not a quota, is that every user, if every user puts 25 terabytes in it, we have 10 times too little space. So it's really a maximum to make sure that there's no runaway jobs. So if you want to know how much you could do, if everybody did, it's 2.5 terabytes. But it really is, not everybody needs a lot of space, and it's for temporary data. So use it. You'll probably be fine within the limits. If you are one of those users that needs way more, let us know, and let us know why. But that's so it's really a safeguard. There's no quota. It's just temporary space. Yeah.
Okay, so 25 is for a user, so it's quite a lot. But then your group also has much bigger allocation. Any other questions?
Could we use Asper to download the data? Or
Which tool?
Asper.
Asperl.
ASPERA.
I think we can make it work.
Yeah.
I think so.
I guess the best answer would be just write us an email what you want, and we'll find a way to accommodate you if you need something specific. Okay.
Okay.
Yeah. Welcome. So keep in mind that today we have a couple of more sessions. So right now we have a snug meeting where we're going to listen to some presentation, I think. And at 1 o'clock we have Intro to Linux, where one of our colleagues will tell you how to start using terminal and help you to get going. So this session was very theoretical, but the other one will actually make sure that you are running everything properly. You get to play, and we get to teach you how to play properly. Okay, so it's 1 o'clock, and it's got a couple of hours, or maybe even longer. So thank you for coming. If you have any other questions, please send us an email. And I think next month we will also have another intro. So if you still have questions, you can come again. But so far, that's it. Thank you.
Thank you.
Thank you.
Okay.
Yeah.
So, so